Welcome to this lesson on orbital diagrams. Orbital diagrams are a powerful visual tool that helps us understand how electrons are arranged in atoms. They provide a clear picture of electron configuration that goes beyond simple notation. By the end of this lesson, you'll be able to draw these diagrams confidently and understand what they tell us about atomic structure. Orbital diagrams serve three important purposes. First, they give us a visual representation of how electrons are distributed throughout an atom. Second, they show us exactly which orbitals the electrons occupy at different energy levels. Third, and very importantly, they display the spin direction of each electron. This spin property is a fundamental characteristic of electrons that we'll explore further as we go. Every orbital diagram starts with a simple building block, the box. Each box represents one orbital, which is a region of space where electrons can be found. Here's a crucial fact to remember. Each orbital, represented by one box, can hold a maximum of 2 electrons. An empty box means that particular orbital currently has no electrons in it. We represent electrons using arrows inside the boxes. An upward-pointing arrow represents an electron with spin up, while a downward-pointing arrow represents an electron with spin down. These arrows are more than just symbols. They tell us about a quantum property called spin. Each electron must have either spin up or spin down, and this becomes important when we place multiple electrons in the same orbital. Drawing orbital diagrams correctly requires following 3 fundamental rules. Rule 1 is the Aufbau Principle, which states that electrons fill the lowest energy orbitals first before moving to higher energy levels. Rule 2 is the Pauli Exclusion Principle, which limits each orbital to a maximum of 2 electrons. Rule 3 is Hund's rule, which tells us that electrons will fill orbitals singly first, spreading out as much as possible before they start pairing up in the same orbital. Let's apply these rules to carbon, which has 6 electrons. We start with the 1s orbital, which fills completely with 2 electrons shown as up and down arrows. Next, the 2s orbital also fills with 2 electrons. Now we have 2 electrons remaining, and they go into the 2p sublevel. The 2p sublevel has 3 orbitals. Following Hund's rule, these last 2 electrons spread out, each going into separate orbitals with parallel spins, both pointing up. This minimizes electron repulsion. Oxygen has 8 electrons, so let's see how the diagram changes. The 1s orbital fills with 2 electrons, and the 2s orbital fills with 2 electrons, just like carbon. That leaves 4 electrons for the 2p sublevel. The first 3 electrons spread out, one in each of the 3p orbitals, all with spin up. The 4th electron must now pair up in one of the occupied p orbitals with spin down. Notice how electrons fill singly first, then pairing begins. You now have everything you need to draw orbital diagrams. Step 1. Draw boxes for each orbital in the appropriate sublevels, remembering that S has 1 box, P has 3 boxes, D has 5 boxes, and F has 7 boxes. Step 2. Add electrons as arrows following the 3 rules we discussed. Step 3. Always fill from lowest energy to highest, spread electrons out in degenerate orbitals first, then pair them up. With practice, this will become second nature. Keep practicing with different elements to master this essential skill.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.